In this lesson we're going to look at the null factor law. The word null means zero, so we'll be looking at how a zero factor works in an equation. Basically we know that if you're multiplying two numbers together and you get zero, then one of them has to be zero. If you did 0 times 7, you're going to get 0. In fact, it doesn't matter what you put in here. Or if you have a 10 here, for example, and you need it to multiply by something to get 0, then that thing in the box has to be 0. Two numbers multiply to get 0, what do you know about them? That you know that one of them has to be 0. You know that if you multiply anything by 0, the result is 0. The converse of that is if you have a result of 0, then you know at least one of the factors must be 0. That's what we said here. If you know your answer is 0, then one or the other has to be 0. Okay, let's have a look and see how that applies to our quadratics. Use the null factor law to solve the following equations. So null means 0, and in order to use the null factor law, we first of all have to have our equations in factor form. So if we look at this, this is saying 3 times some number equals 0. So I'm multiplying two things together and I get 0. Then one or the other has to be 0. This one's 3, it's not 0. So it means that x has to be equal to 0. That's the only way you could get an answer of 0. In number 2 here, the null factor law, we've got a 0 here on the right hand side. We first of all have to get factors here. So we need to go to our knowledge of factorising and recognise that we have a common factor of x here. So if you take that out, you're going to have that as your two brackets. The null factor law now is saying that either this equals 0 or this bit equals 0. So we're saying either x equals 0 or x minus 2 equals 0. X equals 0, we've actually got an answer there, or we've just got to do a little bit of algebra here. I still haven't solved it for x. It's x minus 2, so I need to add 2 to both sides. So the value of x could be 2. So this statement is true if x is 0 or x is 2, and we would write that as x is either 0 or 2. It's not a coordinate, I haven't put brackets around it, but these are just the two solutions. And you could go and substitute those in to do a check. In my equation, I'm saying that 0 squared minus 2 lots of 0, yeah, that's equal to 0. Let's check if we put a 2 in. 2 squared minus 2 lots of 2, 4 take 4 equals 0. So those are two solutions that we've found. Let's move over to number 3. X squared minus 16 equals 0. We have to get them into factor form before you can use the null factor law. I've got two terms separated by a minus. I can use my dots. So I could write it as that, which means I'm going to have x minus 4, x plus 4 as my two factors. So that's saying either x minus 4 equals 0 or x plus 4 equals 0. Doing a little bit of algebra, I need to add 4 to both sides. So x is going to be 4. Here I take 4 from both sides. X is going to be minus 4. You'll always find that when you solve each bracket, the value of x is just going to be whatever number you put in here to make this equal 0. So if I've got to take 4 away from it, my answer has to be 4. 4 take 4 is 0. Minus 4 plus 4 is 0. These solutions, minus 4 and plus 4, can be written a little bit more concise, so we can say x can either be plus or minus 4. So rather than write it as two separate ones like this, we use the plus minus symbol. So that just means plus or minus. Moving along, let's try something a little bit more complicated. Over here, 2x squared equals 50. and we need to solve using the null factor law. Over on this slide, everything had an equals 0 on the right hand side. Here we've got an equals 50, so we have to first of all get the equals 0 bit. So what I'll do is take 50 from both sides, so I'm going to end up with a 0. So I'll have 2x squared minus 50 equals 0. Then I have a common factor of 2. I'll end up with that. Then I've got two terms separated by a minus. I can use a dots. So I'm going to have x minus 5x plus 5. Then the null factor law is telling me that either this bracket is 0 or that one. So x minus 5 equals 0 or x plus 5 equals 0. So x is either going to be 5 or x is going to be minus 5. So just doing your solve, add 5 to both sides, take 5 from both sides. So x is either plus or minus 5. Number 5 over here, it's a trinomial that equals 0. We have to factorise it, and you have to remember all of your different factorising techniques. The trinomial means we have to get factors of plus 6 that add to minus 5. Remember with a 1 here, 1 times 6 is 6. I have to add to minus 5. So I'm going to get minus 2 and minus 3. Now if you are a shortcut person, just bear with us while we do this. X minus 2 minus 3, x minus 2 is 0. If you're a shortcut person, you could have gone straight from there to here. Either way, you've gotten to this point. Two brackets multiply by each other and they get 0. The null factor law tells us it's either that equals 0 or that equals 0. So it follows that x is 2 or x is 3. There's our two solutions. It's not a coordinate, I haven't got brackets around it, but that's just two different values of x. But if you were to substitute it back in here, you would get 0. Okay, so why do we do all this? What's it all for? Remember what I keep saying, the whole point of all of this quadratic algebra is to be able to get a graph. You need to be able to sketch a graph. So if I was to give you this and ask you to sketch it, the two most important parts are the y-intercept and the x-intercept. The y-intercept, we will make x equals 0 just like we did in linear. So we're going to have y equals 0 squared minus 5 zeros plus 6. So our y-intercept is 6. Thinking about a graph, that means then that up here at 6, our graph is going to cut the y-axis at 6. We now have to get the x-intercept, and to get the x-intercept, you make y equals 0 just like you did in linear, which means instead of y, I'm going to write 0. This sum here now is exactly what we did over on this last page. Our quadratic trinomial equals 0. Same quadratic, it equals 0. We would go ahead and factorise it. And we would get x minus 2, x minus 3 equals 0. So our 2x solutions are 2 and 3. I haven't done that in any detail because we did it on the previous slide. So that's telling us that the x-intercepts are at 2 and at 3. So here's x, 1, 2, 3. So our x-intercepts are here at 2 and another one at 3. So our graph is going to do something like this. So a parabola is going to go there. The last thing that we need to find with our parabola is this point here that we call the turning point. So the turning point there is the last little piece in our jigsaw puzzle that we're going to need to work on, but we'll do that at another time. Good luck with solving.